Hi viewers, welcome to another class where we are going to deal with smart materials, nickel titanium alloy, generally called as nitinol. I am Dr. S. Rekha, Associate Professor, RMK Engineering College, Chennai. Let us move into the topic. Nitinol, nickel titanium alloy, generally called as nitinol. Why it is called as nitinol? So it is found in the Naval Ordnance Laboratory in the year 1965. So it is called as nitinol. What is the composition? 56% of nickel and 44% of titanium. This nitinol remembers its original shape up to a temperature of 500 degrees Celsius, can be trained up 8 to 10 times more than spring steel without permanent deformation. Okay, if I go for more training, permanently it undergoes deformation. Okay, before that, 8 to 10 times we can train this material so that it takes two-way shape memory alloy. Physical properties. So appearance, it is bright silvery metal. Density, it is 6.4 gram per centimeter cube. Melting point, it is around 1310 degrees Celsius. Resistivity, it is 82 ohms per centimeter in high temperature and 76 ohms centimeter at low temperature. Thermal conductivity, it has 0.1 watt per centimeter per degree Celsius. Heat capacity, so it is 0.077 calorie per gram per degree Celsius. Latent heat, this material has a latent heat of 5.78 calorie per gram. Extremely tight compositional control is required for the production of this nitinol. Okay. Extraordinary reactivity of titanium also makes it another problem in production of this alloy. Okay, two primary melting methods are presented for production of nitinol. One is vacuum arc remelting. In this, the electric arc is struck between water-cooled copper strike plate. Okay, we have a copper strike plate which is cooled from outside, and the raw material, because this titanium undergoes reaction, no, so we want to avoid that. Water cooled copper mold is used for melting the constituent in high vacuum to prevent carbon introduction. So here we get a very good alloy output. We have another method, vacuum induction melting. Raw material are heated in a carbon crucible using alternative magnetic field. This is also accompanied in high vacuum, but here there is a carbon introduction into the process. Either of the method we can use. If we are able to allow little bit of carbon content, there is no issue, you can go with it. But certain application doesn't need any carbon content, it wants the pure form, then we have to go for vacuum arc remelting. Okay. So already I have explained in SMA, and nitinol also has the same configuration. The figure, you can see that small dot and the larger dot. Okay. So one is nickel, another one is titanium. So this is the twinned martensite phase, and this is deformed martensite phase. Now on heating, you get straightened austenite phase. Upon cooling, again it gets twinning. Okay. So this is nickel titanium alloy. So application, it finds application is orthodontic application. Okay. So here you can see that teeth are irregular in shape, means according to the need of, it can be tailor made. I can say simply, I can say it can be tailor made, this nitinol wire. So it acts as a spring. Okay, super elastic property is utilized. So it compresses the teeth, and slowly it gets into its regular form. And also this wire can also be used for the backbone straightening. Okay, problem in the backbone, the nitinol wire can help in straightening your backbone. Other applications, nitinol wire. nitinol is mainly used as wire. See here we have the stent which is made up of wire. This is the blood flow stent. Already I have given you a detailed explanation is just as smart memory alloy. Okay, so it can be used as an actuator wire. That application also I have explained. Okay, and it finds numerous application as guide wire, stylettes, orthodontic file. Just last slide I showed you. Nitinol stent, the most important application of nitinol wire is nitinol stent. You can see here in the figure. Okay, so endovascular stent which are highly useful in treating various heart diseases, right? See, this is the fat content which is blocking your vein for the blood flow. Okay, so it gets pressurized. Now, what we do, we apply this stent in between. We go and place this stent in between. First, this stent is squeezed and taken through this vein and kept here. Then, with the help of a balloon, it is blown out. Pressure is applied, so it opens up. When it opens up, so it brings a pathway for the blood to flow here. Okay, it opens the pathway for the blood to easily flow. So nowadays, no need of doing bypass surgery, just keeping a stent. But provided your heart, your block should be minimum 1 or 2, not more than that. Okay, then it is easy. And it should not have clusters of blocks in the same area. Okay. One more important application of this nitinol is stone retrieval basket. See here, we have the figure here. Okay. So this can be squeezed into smaller form, blown into larger size. Okay. Whatever may be the stone size. Okay. So that stone size, it opens up immediately and can be removed. Gallbladder stones can be removed using this basket. Okay, this is also made up of nitinol wire. The shape change is very helping them to utilize this. Okay. Other uses we have used in retractable antennas. Okay, it is cryofit hydraulic coupling. SMA is used in cryofit hydraulic coupling. See here we have the real-time application. This is one coupling. This is another coupling. This is another coupling where we couple it, we join it together. Okay, see here we have the figure how the coupling is done. We have two different tubes. In between we put this nitinol wire. Okay, nitinol body, so that keeps it intact. Spring action we put it, right? So always it holds it tight. If I do any other thing, there is a gap in between. But when I use this nitinol wire, it makes it completely tight. So all these things, even it can be used for cryofoot compatible. See all the three directions. Okay. So that the two different material or the tube can be held together. Okay. So that is called cryofit hydraulic coupling. Okay. Used as spring, shock absorber, valve, aerospace launching mechanism, stepping motors, digital SMA stepping motors are also used in robotic control. In robotic control, this digital SMA motors are used. Okay. For further applications, you can go and watch my previous video of SMA where I've given different applications there also. Thank you, students. Let us meet in another video where I'll be discussing on chromogenic materials. Thank you.